Hi, everybody. We are just waiting for all our attendees to join, and I'm your host for this evening, Santina Farinella, and I'll kick off in a couple of minutes with a brief introduction. Amazing. I think everybody's in. Welcome to everybody. It's amazing to meet you all this evening. We have a super attendance for Shopify's Women Coding the Future event presented this evening by Gift Igwenu, who I'm going to introduce shortly in partnership with G Sharp. Just a couple of details about She Sharp. She Sharp is a not-profit foundation based in Amsterdam that fosters diversity and inclusion in technology and entrepreneurship. She Sharp's goal is to provide opportunities for underrepresented individuals to share their passions, learnings, stories, projects, or challenges that they've overcome. We're so excited to partner with She Sharp today to bring you this new event series, Women Coding the Future, which aims to continue celebrating and empowering women, and more specifically women in development, beyond Women's History Month. So stay tuned for future event dates and details later this year. My name is Santina Farinella. I lead app partnerships in Europe for Shopify. I'm engaging with developers across Europe every day who are building apps for Shopify, extending Shopify's platform to meet merchant needs through our app ecosystem. I was previously a co-founder of a developer tool startup prior to joining Shopify. My startup was based in Dublin, Ireland, and I've also worked in online travel and e-commerce for over 15 years. Writing clean code, like providing continuity to enable and empower developer teams, is a theme that's very close to my heart because I know firsthand the impact of not doing so, not just for the business, but for the entire team behind it. So I'm also really interested to hear Gift's experience today. From my experience, your code is your IP, and therefore it's also an asset, whether your business succeeds or not. So with that, I'm so happy to introduce Gift today. Gift is a developer advocate at Cloudflare, and she's going to share her experience about the importance of being able to write clean and easy to understand code, as well as the opportunity cost created by writing bad code. Gift has over 5 years experience in web development and building tools to help businesses grow. In her previous role, she was a front-end developer prior to becoming a developer advocate. Day to day, Gift shares her experience in web development, Jamstack, career-related topics, and developer lifestyle videos with people seeking guidance in the tech industry, and with developer communities on Twitter, GitHub, YouTube, and more, sharing helpful resources for developers as well as curating developer resources herself. You should definitely check Gift out. I'm now delighted to hand you over to Gift for her presentation, at the end of which we're going to have a Q&A. So please get your questions ready and post them in the question function, which you should see on the right-hand side of your screen. And also, please do feel free to share your reactions and comments to Gift's talk and show support as we go. At the end of the presentation, and Q&A, I'm going to direct you to some breakout sessions, but I'm going to share a little bit more detail with you on that closer to the time. So for right now, over to you, Gift.
Thank you so much, Santina. I am absolutely excited to be kicking off this series. I'm just going to go ahead and share my screen. Great. Hi, everyone. I Gift, like Santina mentioned. I currently work as a developer advocate at Cloudflare. And today I'm really excited to be speaking about this topic, writing clean code for humans, because I think it's actually a very important topic for us as developers. My talk today is all about writing clean code. I wish I was in your room together with all of you, but since you're not, we're currently doing this virtually. I would like to throw this question to the room. Like, why does writing clean code matter? If I was to ask you this question, if we were in a physical space, you would probably have something to say back to me. It could be that your reason might be because it's a good way to keep your code maintainable, or that because it's a good practice when you're working with a large team. These two sentences actually true, and they make sense. Like when you ask that question, it makes sense to think about it like, oh, this is actually correct. But in today's situation, like, is that the actual case for today? Like, do people actually know that writing clean code is important, especially when you're working with a team, or it helps keep your code maintainable? This is somewhat debatable, especially when you're working with developers that probably are working alone, like they're the sole developers on a team, or developers that currently don't know the clean coding principles to follow, and they can't really tell what the difference between good and bad code is, right? And that brings me to the next thing. How do you classify bad code? Can anyone relate to this image? I think this is the best depiction of good versus bad code that I've seen. On the right, we have an example of bad code. And this is essentially a code review in progress. And you, 1 minute. Great. Like I was saying, this is actually a code review in progress. And on the left, you see an example of code being reviewed. There are little swear words. The engineer reviewing the code is happy. On the right, you actually have an example of bad code being reviewed. And you see that there is a lot of swear words coming out of that room. I would like for us to spend a few minutes looking at this code block, and you can leave your responses in chats. That would be great to see. But what do you think is actually wrong with this code? Just by glancing at it, can you actually tell the errors or specifically things that could be better? Right here in this code base, I'm using very non-descriptive variable names. And that's one thing that I find that's very common with developers not explicitly stating descriptive names for variables or functions, right? And this is not great, especially when you work with other people on your team. Like this example here is Shopify's admin API. And if in this case, I'm setting a variable to be X or Y, that's not very explanatory, especially when you use it like in different parts of your code. It's not the best, right? What would be a better example would be essentially calling your functions or your variable exactly what they are. In our previous example, I was calling this X and Y, which doesn't really make any sense, right? But it's actually better to correctly name the variables like they. Having shown this example, I'm sure you already know like an example of what bad code is, and I've explained how you can actually see, or just by looking at a code base, you can already tell that, oh, having non-descriptive variable names is not great, so I should probably fix that. Bad code is code that is difficult to understand, and in a long run, it creates technical debt. Bad code is code that nobody understands except the person who wrote it. Sometimes that might not even be the case. This is another good example. Like you could literally write code that you come back to in a few months and you literally don't know what you did. I found this example on Twitter a couple of days ago and I thought it was actually very hilarious. This is an example of bad code, and essentially what it's saying there is whoever comes back to work on this should leave like an additional string to say how many hours they spent trying to understand it, because the person that wrote it, don't understand it. And yeah, it's not great. Bad code exists because a lot of developers try to rush to meet deadlines, or They are just looking forward to get the product released that you're working on and not spending enough time needed to make the code clean. And I think we've all been there. Most of us are guilty of just leaving the code messy. And when we come back, we'll be like, oh, I'll probably come back to this to refactor it. But really, that never happens because your coming back to refactor it later becomes like you never happen to do it, right? And that brings me to this concept, the LeBlanc's law, later equals never. You say you would want to do something later, but actually you never come back to doing it. This doesn't just apply to programming or code, like it applies to everything in life, right? There are things that you probably have on your to-do list that you said you would do, but you actually never went back to do it. And in a long run, what happens is this will cost you and also your team further down the line, because by leaving the code messy, it's going to eventually create technical debt, which will reduce the productivity of the developers on the team because they would spend more time trying to fix the bugs that comes as a result of the error-prone code that you've written. In essence, increasing the time it takes for you to ship your code, and then everybody on the team gets, fed up with the code base. What happens sometimes is the team or the engineering manager decides that, oh, I think it's time for us to actually rewrite this entire code base. But that's not the solution, because the main solution there is that you did not prioritize writing clean code. So having established now what bad code is, and we know that there are people that don't really pay attention to writing clean code, what are some best practices that we can employ to help us write better looking code? And before I even share some best practices, I would also like to explain or share exactly what I think clean code is. There is no one definition to clean code. Like, if you should go on to read articles, resources, you'd see that everybody has different explanation of what they think clean code is. And for me personally, I think clean code is code that is comprehensive and easy to understand. It's super great that not even you understand this. Literally anybody takes your code and they can understand what you wrote, right? Clean code always looks like it was written by someone who cares. And this is a quote from Michael Feathers. Now let's go over some best practices to keep in mind when you are writing code going forward. I think the bane of developers, of our existence as developers, is having to name anything. So having to name functions, variables. Literally, there's even this quote that says, there are only two hard things in computer science: cache invalidation and naming things. I think naming things is super important, like having proper descriptive names for your variables, your functions, classes, and so on. It's really important when you think about the concept of clean code. This is also another meme that I think was funny. When you're trying to think of a very thoughtful name to give your variable, you just think of something. You can't actually think of something and then you just go with X, which of course is not the best, right? So one thing you should always know in terms of naming conventions for your variables or function is to use intentional revealing names. I already shared an example from earlier. Always make sure that your variable names, functions name are very descriptive and they actually tell exactly what your function, your variable is doing, right? Like if I look at, for example, this example I had here, I initially was calling it const s awaits Shopify. It's using Shopify's API. And this is actually a bad example of how to name your variables. But this is better because I'm assigning it names that are pretty descriptive, names that could tell anyone looking at this code that, oh, this is what this actually does, right? From the name that I've given it. Also important to use pronounceable names. I know I said use names that, tells you what the variable function is doing. That's great. if you've worked with dates in JavaScript, you know that you have like year, this DDD and so on. I don't think that's descriptive enough if you're going to go with that. So also try as much as possible if you're using, like, for example, my example here is I'm trying to get the year of my birthday, right? This is not actually my birthday, but yeah, I'm just trying to get the year. And what could be a better example here would be actually calling it birthday. That way, somebody or anybody looking at the code, or even myself coming back to this, don't have to think, what's the actual use case? Like, why did I name this year? So using pronounceable names is also very important. The next thing I would like to share here is to write clean functions. Functions are what make your code actually very usable and easy to read and maintain. And if there's one rule that you should stick to when it comes to functions, is that your functions should do just one thing. They should do it well, and they should just do that thing only. But that's not the case, right? Because nowadays, people go ahead to try to cram all the logic that they have inside one function. I have this example here. It's doing this function is called get customer. But if you pay close attention at the function, it's actually doing two things. It's getting the customer name and the customer address. What would be a better example would be to actually separate this two different logic into two functions. This is a demo example, but if you think of this in the context of a real world application, you probably have in that function more than 50 to 60 lines of code. And eventually it will add up because you always want to be adding functionalities to your application. And then that just keeps growing into, a function that you probably not understand when you come back to it because it's doing so many things. So a good approach to follow when you're creating functions or writing functions is to make sure that it's just doing one thing. The moment you find that my function is trying to do something else, that's the best moment to actually abstract it. So create a different function and call it wherever you need it. The essence of having functions in the first place is to have reusable code in your app. Another good one, I think people will probably miss or have different opinions about, is writing good code comments. Commenting code is honestly one of the things that people have different opinions about. Like, even preparing this talk, I was asking a couple of people and they also told me that, well, I don't know, I probably would not want to write comments if someone's code is actually very understandable. I don't think that there should be comments in it. There's also the folks that would say, well, I think it depends. You could actually still have comments in your code, but make sure it's like super descriptive, or everybody has their opinions about writing comments. But here's what I think. I think commenting your code could be very helpful. It could be a helpful tool to use depending on how you use it. There are good and bad ways of using comments in your code, and I'll share some of them with you. These are some bad examples that I've seen. Never explain what your code is doing, like literally word for word. I think I've seen this a couple of times where you have like a JavaScript file, and then with every function, you literally have an explanation to go with the code. If you feel like it's not explanatory, like if you feel like you have to explain every line of code, then you're probably doing something wrong, right? I think it's acceptable to have this in two scenarios. First, if you're writing a documentation, like if you're part of a documentation team and you're writing a code example that goes into a documentation, you want your users to be able to understand what that code is doing, then it's fine to have that example. Or if you're writing a tutorial or a blog post, you want to step through each code by explaining it. Those are like different scenarios where I feel like it's okay to do this. But if you actually are doing this in real production code, then I think that's not the best way to go about it. Secondly, avoid commenting out code and leaving it there. I mean, that's why we have Git, right? With Git, you can always go back to a previous version of your code. You don't need to actually save it. I'm guilty of this. I've done this a couple of times when I think about a better way to implement a function and I'm like, oh, probably I'll come back to this and I comment it out. By doing that, you most likely forget about it, especially when you're working like in a large code base. And just leaving out commented code without context, when other engineers come or find that, they don't know what that's supposed to be doing there, because of course there is no context to why you commented it out. Most likely that would be the case, or it just litters the entire code base, right? So avoid commenting out code. If you really want to, you can actually make a Git commit and say something like, I probably come back to this when I'm ready, or you can always find that in your Git history, right? Also avoid journal comments. Like, this is also what Git does for you, right? Journal comments is essentially like adding a comment to say why you did a specific thing, or trying to get like a specific messaging in at a specific time so you remember. It doesn't really make sense, because you can also do the same thing with just committing, or you can also stash things and keep it so that when you're ready to come back to it, you get it back from your Git stash. Yeah, I don't think these are good examples of writing comments in your code, but what are some good ones? Personally, I feel like it's okay to write comments when you are, for example, adding in like a open source license. I know that there are companies that use some open source libraries, and it's okay to add like a code block stating the license for the code, so that other people knows that, oh, this probably has like an MIT license or a GNU license. You can also include that in your code. That's fine. Another example is something called JSDoc. You can also document your code using comments. So there is a library called JSDoc, and what it helps you do is eventually create like an API documentation for your code. So in this example here, I have storefront access token. I have a storefront post API, and I'm documenting it by saying that I passed in two parameters there, the request and the response objects. And this is just, it helps in two ways. Like I said, it helps you make your API documentation. It also helps, like, at a first glance, anybody sees this, they know this is what this function is doing, right? Which is very helpful. Also, this is also very debatable. I like to add to-dos or refactor comments in my code, just so that I can easily search them out. There are times when you might want to have like a quick win, and you go through your code to search for probably things that you've tagged with to do or refactor, and then it's easier to find them. This is another helpful way of keeping comments in your code that I found. It could also be debatable because it still says the same thing where I said you don't have to have commented code. But I feel like, excuse me, I feel like having to-dos is helpful, especially when you find that there is a better way that you can actually make your code, or probably you're trying to work on something, but you have like ideas for how to make something else better. And then you put a comment to say, oh, you come back to it. But always remember that you actually have to come back to do the thing that you place the to-dos for. Another best practice that I like to share is formatting and following a style guide when you're writing code. You should always make sure that your code is properly formatted, and there are so many tools available to help you make this work. I'll be sharing some examples that are JavaScript specific, but I think that there are a lot of other tools out there to help you. Most times when you're working on a project with a team, it's important to enforce a formatting style that everyone has to stick to. You want to have a consistent style all across the code and not the other way around. There are two examples of style guides that are out there for you to use: the Airbnb style guide and the JavaScript standard style guide. These are JavaScript specific style guides, but if you search for other framework specific ones, I'm sure you'd find. Next, follow a consistent style. This follows what I just said about following a style guide. A lot of times when you have different people working on a code base, it's easy for people to derail from, following the specific style guide if you have one set. If you don't have one set, then it's so easy to make these mistakes, right? It's so easy to have like people using snake case, camel case, kebab case without actually following. For example, here I have the first two variables, they're using two different case and doesn't really look like the best style guide to follow, or it's not a consistent style, right? And imagine you have like different ways of writing functions all over your code. Like, it's not great. A better way is to use like a tool like ESLint to enforce your style guide. So if you as a collective member of a team or your team decides that we're going to stick with ESLint to help us and then they set specific rules, all of this could also be automated, right? You don't need to actually go to look through each variable name to make sure it's following a specific style guide. Like, there are tools that would allow you automate it, that even when you try to commit your code to GitHub, it doesn't allow it because you are missing some you're not following the team specific style guide. Next, we have testing. And I know that this is also another thing that you'd hear a lot of people say, well, I'll probably do it if the team enforces it or not. I think testing is actually very important. Testing your code helps you ship error-free code into production. It also helps you think of the implementation before actually writing the code. The law of TDD, test-driven development, follows three specific methods. So first, you write your code to pass a failing unit test, and make sure that you're writing no more of a unit test than sufficient to fail, and write no more production code than necessary to pass the one failing test. Good tests should follow the first principle. So in TDD, there is this thing called first principle. Essentially states that your code should be fast. You should write tests that runs super fast. Your code or your test code should be isolated, meaning that you should make sure that you're not depending on a lot on the code that you're testing, right? Make sure that your code is repeatable. You can run it multiple times. The last two, your test code should be self-validating and timely. This is the first principle. And when you're thinking about writing test code or following the TDD principles, this is something that comes to mind and follows like a best practice for writing tests. Errors. We already know that our code will most likely fail. Anything can go wrong. Maybe you missed like a trailing space, or you forget to pass in the correct parameters that you're supposed to be passing. Things like this are likely going to happen. But how do you actually ensure that you handle it before your code gets to production? One way of doing this is by using try-catch exceptions. This makes your code look cleaner and you avoid any necessary if statements. So one thing I like to recommend is whenever you're using a try-catch statement, make sure that you're actually handling the errors and you're not only just returning like a console.log. I think this is very common when you have like a try statement. Great, you're probably trying to fetch something from an API or do something in the try block. In the catch block, most people just end up console logging the error they get from that. But I think you can actually do more with that error. You can either send it to a error monitoring service like Sentry, or send like the error to the dashboard or back to the user so they know exactly what is happening when the code or the app breaks. So we've gone through some best practices and things you should look out for and ways to actually write clean code. There is more to writing clean code, and I would like to share some of them. So we have this thing called clean code principles. These are concepts coined by great engineers, and they've stood the test of time. The first principle I'd like to share is KISS. It literally means keep it simple, stupid. And this is a principle that states that the most system work best if you keep it simple rather than making it overly complicated. And this is a very easy problem to fall into. Like if you're building a feature or you're working on an application, it's easy to think at the first glance of the best possible things to do. Oh, I like to build like Facebook in 2 weeks. That's not possible. So if you're thinking about building a feature out, it's always important to keep it simple first. Like try to start from the basic stage possible and then build up from that. The next one is always keep your code dry. So don't repeat yourself. Every piece of knowledge must have a single authoritative representation within a system. That's what the dry principle follows. And to avoid dry code, it's important, or one best practice is to try to break your code down into smaller reusable code. So it's okay to have like a lot of functions that do one thing, as long as you're like separating it out. So if you notice that you're writing a function that spans over like 50 lines of code and you're probably doing multiple things in that function, then you know it's time to break it out into smaller reusable functions. I like this meme, and there is also like a contrasting principle. It's called wet, so dry and wet, and it essentially means we enjoy typing. Or I think that if you are not writing dry code, what you would actually call your code is wet code. I don't know, but yeah, I liked that meme. The next principle here is YAGNI, and it means you ain't gonna need it. It's a principle that states that you should not add functionality until deemed necessary. So this also like ties back to the first one I shared, where you should not overcomplicate your code. So always implement things when you actually need them, and never when you just foresee that, oh, this would be a nice addition to this, so I should probably work on it now. The YAGNI principle follows like a very good structure. So if you know that this is the right feature I need to be working on now, you should spend more of your time working on it there. And that's why I see that people have backlog, or they have like a roadmap, right? Where you like have, or you find that you have a good idea. Probably don't spend so much time on it now. Add it to the backlog or add it to the roadmap so you can come back to it. Because what I've seen happen is when there is like too many contexts, or when there are like too many things going on, or speaking from the perspective of myself as an engineer, when I have too many things going on at the same time, they kind of suffer, because how the brain works is you're mostly concentrated on one of those things, and you can't. I mean, people that are productivity gurus probably know how to do multiple things at the same time. But I feel like if you focus on one thing at the time, that way you are more productive and you actually get good output. I also like this other principle, the Boy Scout rule. and it's actually something different from programming, but it was coined to become a programming or clean code principle. The real Boy Scout rule states that always leave the campground cleaner than you found it. And in programming translates to always leave your code cleaner than you found it. So I think this could apply to anybody, right? If you're working in a code base and you find that I could actually improve the way this is written, or maybe just abstracting this into a smaller file to make the code look more cleaner would be something that I would spend like 5 minutes doing, right? Just finding those small wins to make sure that you're making your code cleaner and more maintainable in the long run is what the Boy Scouts rule is all about. So I need you to ask yourself these questions. How can you tell that your code is clean going over like all the things that I've shared in this talk? I like to think that if I can get my code to someone else and they understand what I've written, that's essentially clean code. Like if I don't get questions back, oh, Gift, what does this do? Or how does this actually work? Then probably I did well by writing clean code. How easy is it going to be to add more features further down the line? Like if you look at your code base, is it easy to like add new things, or do you have to like focus more of your energy trying to fix bugs and you don't actually have enough time to work on new features? Do you constantly break existing functionality when you're trying to make changes? These are questions you should ask just to get like a sense of how good your code has been written. And if by going through these questions, you can assure yourself that, oh, this is good. I think I've done well by keeping my code maintainable, making sure that other people can understand it. And then I think you've done a great job. The consequences of writing bad code can be seen if you answer no's to the questions that I said, right? And it essentially means that there's some work that needs to be done to make your code cleaner and easy for anyone to understand. And essentially, to recap everything I've shared today, I shared with you an example of what bad code looks like. I also shared how to make it look better. And then I shared best practices that you could actually follow to writing clean code. Always use meaningful naming conventions, write clean functions. Good comments are great. Remember, there are two contrasting ways you can actually add comments to your code. So know the best ones to follow. Always use like a formatting tool or a style guide when you're writing code. Follow the TDD principles is super important, and also remember to handle errors correctly. Following that, I also shared clean code principles. The KISS principle, keep it simple, stupid. The DRY principle, don't repeat yourself. Yagni, you ain't gonna need it, so just keep it in your backlog when you actually do need to work on it. And the Boy Scout rule. So the Boy Scout rule, just like as the last thing that I say before I end this talk, always remember to leave the code cleaner than you found it. I think the smallest possible effects that you could add to your code to make it more cleaner is just finding the small wins, like looking out for the things that you could make better without actually spending a lot of time doing it. So what do you do after this talk? Like learning to write clean code is hard work, right? I said all of this in like 30 minutes or less than, but it takes like a lot of practice to learn the code principles. I mean, it's good to have like a concept of, oh, this is what I should be doing. But if you look at it on the other hand, it actually takes practice to get to get into it as a habit, like when you're writing code. So you need a lot of practice to make it stick. So take what you've learned today and begin to slowly work it into your workflow as you continue to write code. Here are some resources that I've included and a few references that helped me prepare this talk. The Clean Code book by Robert Martin. Code Complete is another interesting book that I read. I love it. And this resource, Introduction to Clean Code and Software Design Principles. And finally, the Pluralsight course from Corey House. Thank you so much. I hope you picked up something from what I shared today. I'll be happy to get some questions if you have any.
Amazing. Thank you so much, Gift. That was really accessible and really useful. So thank you so much for putting your time into creating that content to share with us today. Just before we get to the questions, and I can see some great questions coming up in the questions area on the right outside. Just explain kind of what happens next. After the Q&A, we're going to be going into breakout sessions. You can choose which one to join. In the first session, you can meet the speakers, you can meet Gift, ask her any additional questions you might have that we don't get a chance to touch on during the Q&A. So don't worry too much if we don't get to your question, although we're going to try to cover off as many as possible. In the second session, we're going to be talking about building on Shopify. So you can join me in this breakout room if you're curious about what it takes to build on Shopify. In the third breakout session, you can meet the folks behind She Sharp and learn more about their up-and-coming events. The fourth breakout session, working at Shopify. If you're curious about a career at Shopify, you can join this breakout room to talk with our talent team. And in our fifth breakout room, we'll have kind of an open discussion where moderated by Shopify as well, where you can join to chat with other attendees. So let's maybe just go to the questions. And I might start at the top, then Gift from Dara. Does having many different functions in your code affect performance?
Interesting. I think in the long run, what would help when you have like thinking about performance and having too many, does having many, I'm just going to reread the question.
Yeah, of course.
Well, I think it depends on, at the end of the day, to make your code more performant and more maintainable, it will be really helpful to like break it down. So if you have like a function running over like doing multiple things, like I said in the talk, make sure that your function just does one thing.
One thing.
But in the long run, if you find that that's happening, you can always like abstract it into smaller functions and reuse it in the main one. In terms of performance, I'm thinking of like how quick your code will run on the browser. If, for example, you have like a function that's super large, I would say it shouldn't be a problem, but again, it depends on the context of what you're writing. Like, it does really depends on that. But I think if you follow the exact principle that states that you should write, make sure your function does one thing, and having that in mind, you would not even have to bother to try to refactor a function that goes over multiple lines, if that makes sense.
Yeah, absolutely. Thanks for that, Gift. So second question from Rosella. So how do you keep your CSS code clean?
Interesting. For this, I probably recommend using like the Sass library or SCSS library. If you're using just CSS, it's easy to have like one CSS file span over like multiple lines. But what I've seen happen is by using SCSS, Sass, Less, there are so many different CSS methodologies. There's also like BEM out the top of my head that I remember. These have like guidelines for how you can structure like your CSS code. So you can have like different rules to follow on how you can have like your CSS abstracted into smaller files. So, for example, you have like a file for reusable um, colors or font or something you're using. So that's in a separate file. You don't have to have everything in one CSS file essentially. So if you follow like this other, if you follow like this CSS, I don't know if I should call them style guide, then with that you can easily write maintainable CSS code.
Amazing. Thank you. The next question is from Alex Siega. So following dry and single purpose function best practices, do you think that you could modularize your code so much that it becomes less readable? If so, how do you balance readability and functionality?
That's a good question, Alex. And I think I also have like a quick example popping up in my head where with the JavaScript ternary operator, this is like a quick way of, making your if statements or making them look more, should I say, cleaner and easier for people to like, less cluttered. So if you have multiple things in your code, you can easily use a ternary operator. But I also think that there are cases when you could have modularized your code so much that you understand it, but someone else coming in, it will take them a few seconds to get that, oh, this is what you're doing. And in situations like that, I recommend having like, maybe depends on, I think it depends on um how much you think the code is less readable for you. So for example, if you have like a function that does something and you have optimized it to the point that it's now maybe 2 lines of code, do you think that anybody coming would understand it? If so, probably you should, if you think that's the case, then that's good. But if not, then you should probably add more context to help other people understand, because you're not just writing it for yourself, right? You're also writing it for other members of the team to also understand.
Okay, amazing. We have a question about, can we make the slides accessible after the event? I'm not 100% sure on that, Alex, but we'll certainly kind of work to get that information before we close out. Next question, I think, is a comment from Trish, maybe in response to some of the conversation. So I'll move on to the next question from Olive. Regarding commenting the code, should every function have a comment?
Yeah, if you are going to be using the GSDoc library that I recommended, purposely for maybe writing, if you are writing like API code and you want to automatically generate like API documentation for your code, then I would say that would be necessary. But again, I don't know what kind of comments you want to include in every function, but if that's the case, then I think it's absolutely okay to do that with the GSDoc comments. But otherwise, if you have to just like, for example, your function is trying to get a user's address, and you write a comment for that, and you write comments for, maybe the comment just states that the function is trying to get user, then that's not a useful comments to add. So I think if it's okay to add comments for functions if you're just using it for API purposes to document it. Yeah.
Perfect. Just taking a quick time check. I think we'll take 2 more questions and then we might move to the breakout sessions. And I'm just realizing I skipped a question from Nina, I think. So do you have any tips or favorite tools regarding good TDD?
Nice. I love, and maybe this could be very subjective, but I love the view testing library because I write view code, and I know that they also have like one for JavaScript, for React. And in terms of like tools for testing, I always like to also use tools like ESLint. So I feel like in a way, they're like different tools to pick up and add to your TDD practice, but it could very much depend on what kind of code it is. Out the top of my head, I know that if you're writing tests, you should also add continuous integration. So what comes to mind for me is like Travis CI, GitHub Actions, CycleCI. Those are like tools that I have used. So maybe you could check those out.
Great, thanks, Gift. And last question before our breakout sessions. So in a professional setting, when writing code, does the QA give you the tests before you start writing?
Interesting question. So I haven't personally worked on a team with QA engineers. I've had to write my own tests when I'm working. But I think, I don't know if anybody from the chat could answer this because I don't have the experience of working with a QA. But I think that would be their job, right? To if you're following the TDD principles, you need to have tests written first before going off to write the code implementation and then checking that it passed. But I'll be very interested to learn how that actually works between the QA and the developers. But yeah, I don't have the experience.
Fab. Thanks a million. Listen, we'll just before we go to the breakout sessions, I'll give our Milan meetup May 2nd one kind of final shout out, and one of the production crew might share the link to register for that. We'll have a big Shopify team there. I'll be there as well initially on May the 2nd. So look forward to meeting you if you are around. And thank you again, Gift. That was amazing. I really enjoyed listening to you. And really accessible. Fantastic, really. Let's go to our breakout sessions.